As molecules are formed, we identify them as chemical formulas. The formula is a shorthand way of writing what elements are present in a molecule or a compound and how many atoms of each element are present. Water, or H2O, has 2 hydrogen atoms and 1 oxygen atom. Here is the chemical formula for calcium carbonate. The formula tells us the compound is made up of 1 atom of calcium, 1 atom of carbon, and 3 atoms of oxygen. In some chemical formulas, you'll see a subscript number just outside of parentheses, such as for calcium bicarbonate. The parentheses indicate that a group of atoms bonded together into a unit and is acting as a single atom or ion. These are called radicals. This formula indicates that 1 calcium atom has reacted with 2 bicarbonate ions. The formula also tells us that there are a total of 11 atoms present in this compound. 1 atom of calcium, 2 of hydrogen, 2 atoms of carbon, and 6 of oxygen. The percent by weight of each element in a compound can be calculated by using the chemical formula and atomic weights from the periodic table. The first step is to determine the molecular weight of the compound, which is defined as the sum of the atomic weight of all atoms in the compound. Take the weight on the table and multiply it by each atom in the compound to calculate the molecular weight of the compound. The percent by weight formula is percent element by weight equals weight of element in compound divided by molecular weight of compound times 100. The formula for calcium carbonate is CaCO3. To calculate the percent by weight of each element, first find the atomic weight and then calculate the molecular weight of calcium carbonate. Calcium has 1 atom at 40.08, carbon 1 atom at 12.01, and oxygen has 3 atoms at 16 each, for a total of 48. The molecular weight of calcium carbonate is 100.09. You can now plug in this information into the percent by weight formula and determine that calcium accounts for 40% by weight. Carbon is 12% by weight, and oxygen is 48% by weight. The sum of percents does equal 100% as it should. A chemical equation is a shorthand way, through the use of chemical formulas, to write the reaction that takes place when certain chemicals are brought together. As shown in this example, the left side of the equation indicates the reactants or chemicals brought together. The arrow indicates which direction the reaction occurs, and the right side of the equation indicates the products or results of the chemical reaction. If you count the atoms on the left side of the equation and those on the right, the numbers should be the same. This balanced equation accurately represents what happens in a chemical reaction because matter is neither created nor destroyed. The number of atoms of each element going into the reaction are the same as the number coming out. The weights on each side of the equation should also be equal. The practical importance of the weight of each term of the equation is the chemicals shown will always react in the proportions indicated by their weights. Sometimes, chemical reactions are described in terms of moles of a substance. Mole is an abbreviation for grammole. A mole of a substance is a number of grams of that substance, where the number equals the substance's molecular weight. For example, 1 mole of water weighs 18.02 grams. 1 mole of calcium carbonate weighs 100.09 grams. But in the formula, they are both identified as 1 mole each. It's simply another method used to write formulas that you should be aware of. Practice converting from grams to moles if you are expected to use it in a lab setting often. And now, let's move on and talk about solutions. A solution consists of 2 parts, a solvent and a solute, which are completely and evenly mixed. The solute is dissolved in the solvent. In a true solution, such as salt water, the solute will remain dissolved and will not settle out. Salt is the solute and water is the solvent. As a comparison, sand mixed into water does not form a solution because the sand will settle out when the water is left undisturbed. In water treatment, the most common solvent is water, and the solute may be solid, such as dry alum, liquid, such as sulfuric acid, or gaseous, such as chlorine. The term concentration is used as a measure of the amount of solute dissolved in a given amount of solution. Concentrations are expressed or measured in milligrams per liter, grains per gallon, percent strength, molarity, and normality. Milligrams per liter and grains per gallon each express the weight of solute dissolved in a certain volume of solution. Percent strength can be expressed as percent by weight or percent by volume. The percent by weight calculation is most often used in water treatment. The equation used is percent strength by weight equals weight of solute divided by weight of solution times 100. Here's an example of the equation put into use. If 25 pounds of chemical is added to 400 pounds of water, determine the percent strength of solution by weight. The weight of the chemical or solute is given in the problem as 25 pounds. The weight of the solution is the combined weight of the solute and the solvent. So, we know the combined weight is 425 pounds. Now plug this information into the equation. 25 pounds of chemical divided by 425 pounds of solution is 0.059 times 100, which results in an answer of 5.9% strength by weight. Sometimes a particular strength solution will be made up by diluting a strong solution with a weak solution of the same chemical. The new solution will have a concentration somewhere between the weak and the strong solutions. To determine what amounts of weak and strong solutions are needed, use the dilution rule or rectangle method as shown here. Here's how to use the rectangle method in a sample problem. Determine the volumes of a 3% solution and an 8% solution that must be mixed to make 400 gallons of a 5% solution. We start by putting the given concentrations into the proper places in the rectangle. Next, complete the rectangle by subtraction. The circled number on the right side of the rectangle indicates the volume ratios of the solutions to be mixed. The sum of the circled numbers indicates a total of 5 parts. 2 parts of the 5 parts of the new solution should be made up of the 8% solution, and 3 parts out of the 5 parts should be made up of the 3% solution. Using these ratios, we can determine the number of gallons of each solution to be mixed. 2/5 of 400 gallons is 160 gallons of 8% solution, and 3/5 of 400 gallons is 240 gallons of 3% solution. Mixing these amounts will result in 400 gallons of a 5% solution. Although the percent strength method of expressing solution concentration works for many applications of water treatment, a more precise measurement is required in the laboratory. More accurate than percent strength is molarity, which is the number of moles of solute per liter of solution. To determine the number of moles you have of a given compound, compare the total weight of the compound in grams with the compound's molecular weight. The equation is number of moles equals total weight divided by molecular weight. For example, if 150 grams of sodium hydroxide is mixed into water to make a solution, how many moles of solute have been used? You'll need to determine the molecular weight of sodium hydroxide from the periodic table. Sodium has 1 atom at 22.99 atomic weight, oxygen 1 atom at 16, and hydrogen 1 atom at 1.01. So, the total molecular weight of sodium hydroxide is 40. We can now use our equation. Number of moles, or X, equals 150 grams of total weight divided by 40 grams of molecular weight. 3.75 moles of sodium hydroxide were used as a solute. Once the number of moles of solute has been determined, the molarity of a solution may be calculated with the equation. Molarity equals moles of solute divided by liters of solution. If 3.75 moles of sodium hydroxide is dissolved in 12 liters of solution, what is the molarity of the solution? By using the equation, we can determine that 0.3125 is the molarity of the solution.